Next, see the next scheduling algorithm, which is nothing but SRTF. Okay, SRTF means shortest remaining time first scheduling algorithm. Okay, now what is meant by SRTF is exactly similar to SJF. Okay, there is a small difference between SJF and SRTF. In SJF is a non-preemptive scheduling algorithm, whereas our SRTF is a preemptive scheduling algorithm. It is a preemptive version of SJF. Okay. Now you know what is the difference between preemptive non-preemptive, right? Anyway, let's see this. Okay, you will be more. You will make it more clear. Now let's see here. Let us assume we have three processes inside the RAM. Okay, processes P1, P2, and P3, and among these three, process P1 has the highest priority. What does it mean? Process P1 has the least burst time. Okay, and so we have picked process P1, and P1 is currently being executed by our CPU. Now let us assume there is a new process, say process P4 has come to the RAM. Okay. Now at the time at which process P4 came into the RAM, the amount of time which P1 might have to execute further, which means P1 has executed for some time, right? Now let us assume it needs to execute for some more time. Okay. Now this some more time, the remaining time is actually greater than the total execution time of process P4. Okay. See, in simple terms, what I can say is, let us assume process P1 is currently being executed by the CPU. Now, P1 has not completed, right? P1, let us assume P1 has completed. This is the total execution time of process P1, and let us assume P1 has completed till this part, okay? At this point in time, let us assume process P4 came into the RAM, okay? Now, this is the total remaining time which process P1 needs to execute further, right? Let us assume process P4's total execution time is less than this time, okay? It is having lesser time. Now, what does it mean? Process P4 is having higher priority over process P1. Why? Because the amount of time which P1 needs to execute further is actually greater than the amount of time which P4 needs to execute further. Okay? Fine. So one thing is for sure, process P4 is having higher priority over process P1. But in case of non-preemptive scheduling algorithm, which is nothing but SJF, what we could have done is, still we would have continued with process P1 because we are not supposed to preempt any process until completion, right? But in case of SRTF, it is a preemptive version, right? It is a preemptive scheduling algorithm. So what we will be doing is, we will preempt process P1, which means we will preempt process P1 and then we will still schedule process P4. Okay. So this is the only difference between SJF and SRTF. Okay. That there is nothing else. Okay. Fine. Now anyway, let's see this problem. It will make it even more clearer. Okay. As usual, we need to find out the average turnaround time, average waiting time, throughput, and then schedule length. Okay, we need to find out, and we need to use SRTF. Okay, let's see this. First, as usual, we will always draw the Gantt chart, and again, as usual, our Gantt chart will always start with time unit 0. Fine. Now at time unit 0, which are the processes which has arrived? Only process P1 has arrived, right? So process P1 we need not look into any other processes burst time or execution time, because no other process has actually arrived. Okay, we will always pick the process with the shortest execution time among the arrived processes. Okay, now only P1 has arrived, so we will only consider process P1 and we will start with P1. Okay, now until it will execute only for only one time unit. Why? Because at one time unit, process P2 has arrived, and we have executed for one time unit. Okay, the remaining time which we have for process P1 is only 6. Why? Because out of 7 we have executed one time unit, so the remaining time which process P1 needs to execute further is only 6. Okay, now after one time unit, process P2 has come, and priority of process P2 is higher than that of P1 because P2's remaining execution time is less than P1's remaining execution time, right? Okay, see, apart from P1 and P2, no other processes arrived, right? So we need not consider these things. And so we will start continuing with process P2, okay? And we will again execute it for only one time unit. Why? in case if we execute for only one time unit, again process P3 has arrived, right? Now the remaining times, process P1 needs to execute for 6 time units, process P2 needs to execute for 4 time units, and process P3 needs to execute for only 3 time units. So definitely P3 has the least remaining execution time, and so process P3 has the highest priority comparing to process P1 and P2, and so we will continue with process P3. Now again, for how long we will execute process P3? Only till process P4 arrives, right? Only till P4 arrives, which means until 3. Why? Because process P4 needs to execute for only one time unit. Now P3 we have already executed for one time unit. So the remaining execution time of P4 is less than P3, P2 and P1. So P4's priority is higher than all these three processes. So we might have to start continuing with process P4, which means our scheduling algorithm will schedule process P4 to CPU. Fine. Now process P4 will complete its execution. Why? Because until this part only P4 has the least burst time, and after P4 has executed for one time unit, P4 is completely done. Okay, its execution is completely done, and so we will remove P4's PCB completely from the RAM. Okay, because this process has reached the termination state, right? Fine. Now at 4 time units, process P5 has arrived, P6 has not arrived. So out of these, we have 4 processes as of now inside the RAM in ready state. Now out of these 4, which process has the least burst time? Both process P5 and process P3 has the same remaining execution time, right? Now what will you do? See, actually, coming to this, there is no particular rule that among P3 and P5 which one should we proceed. Okay, they should have actually given in the question. There is no such rule that we should go with the least arrival time or we should go with the least process ID or whatever it is. But for this problem, let us assume that they have given in the question that in case if two processes has the same remaining time, then give higher priority to process which has arrived earlier, which means the process with the least arrival time. Okay, among P3 and P5, since both has the same burst time, which means both has the same remaining execution time, we will start continuing with the process which has arrived earlier, and in this process P3 has arrived before process P5. Okay, so we might have to continue with process P3. Okay, see, there is no such rule, right? We are just adding to this question. Okay, fine. Let us assume we have started with process P3, and in case if it continues till 5, what will happen? P6 would have arrived, fine, and it should have executed for one time unit, fine. So let us assume it is P5. Now every process arrived. Okay, every process has arrived. P4 has already done. It has already completed its execution. So fine, we need not consider about P4. Now among these 4 processes, the process with the least burst time is process P3 and P6 has the same remaining burst time, right? In that case, we will go with the process which has arrived earlier, right? Now P3 has arrived earlier than these P6, right? So we might have to continue with P3. Okay, P3 will still continue for one more time unit, which is 6, and so P3 is also done, and P3's PCB will be completely removed from the RAM. Okay, fine. Now among these 4 processes, the process with the least remaining execution time is nothing but process P6. So it will actually see, in case if, remember one point, in case if every process arrived to the RAM. Okay, now as of now every process has arrived to the RAM, right? In that case, our SRTF will behave exactly like SJF. Okay, just analyze this point, you will actually get it. What is the logic behind this? Let us assume every process has arrived to the RAM. Okay, in that case SRTF will behave exactly like SJF. Okay, fine. Now let us assume process P6 is, we have started with process P6 and it has executed for one time unit, fine. So now among processes P1, P2 and P5, the process with the highest priority is nothing but process P5. Okay, so P5 will P5 will be scheduled by the scheduler. See, what I have discussed is, once all the processes has arrived to the ready queue, which means all the processes has come to the RAM, the SRTF scheduling algorithm will behave exactly like SJF. Why? See, now this we will be taking the process P5 because it has the highest priority. Now in case as I keep on decreasing this 2 will become 1, 1 will become 0. If 2 is less than 4 and 6, 1 will also become less than 4 and 6, 0 will also become less than 4 and 6. So this will keep on decreasing, right? See, so let us assume I have taken process P5 and it has gone till 9. Fine. Now see this, all the processes has arrived to the ready queue, and which means all the processes has come to the RAM. Now from then on, this SRTF will behave exactly like SJF, because now P2 has the highest priority. Now as I keep on decreasing P2, which means if I decrease 4 to 3, 3 to 2, 2 to 1, 1 to 0, all these things like 4, 3, 2 and 1 will be less than 6. That's the reason I was saying that SRTF will behave like SJF from the point when all the processes has arrived to the RAM. Okay. So this will be decreased to 0. P2 will continue and then it will go on till 13. Then we have no other process other than to execute process P1. So we will continue with process P1. So it will become 0. It will continue till 19. Okay, that's it. Okay, now let's compute completion time and all this. Okay, completion time. See, when computing completion time in case of any preemptive scheduling algorithm, always start it from the last. Okay, see, in case if you start from the first, what will happen is you will start from here and you will start writing P1 has completed its execution at time unit 1. Okay, that is actually wrong. Okay, so in case if you actually P1 has completed its execution only at time unit 19. So start from the last, you will find 19 and P1's completion time is 19. Okay. Similarly for process P2, its completion time is 13. For process P3, its completion time is at 6. And for process P4, the completion time is at 4. Similarly for process P5, the completion time is at 9. Similarly for process P6, the completion time is at 7. Okay, fine. Now let's compute the average turnaround time. For that we might have to compute the turnaround time of every process, right? Now the turnaround time of process P1, in order to find out the turnaround time of process P1, now we know the turnaround time equal to completion time minus arrival time, right? Now completion time is 19, arrival time is 0 of P1, 19 minus 0 is 19, okay? Similarly 13 minus 1 is 12, 6 minus 2 is 4, 4 minus 3 is 1, 9 minus 4 is 5, 7 minus 5 is 2, okay? This is the turnaround time. Now in case if you want to find out the average turnaround time, just add all these 5 elements, all these 6 turnaround times and then divide it by 6, okay, because we have 6 processes. Fine. Now let's compute the waiting time. Since IO time is 0, since IO time of every process is 0, waiting time of a process is nothing but turnaround time minus burst time, right? So 19 minus 7 is 12, 12 minus 5 is 7, 4 minus 3 is 1, 1 minus 1 is 0, 5 minus 2 is 3, 2 minus 1 is 1, okay? Now you can compute the average waiting time by adding all these 6 waiting times and then dividing it by 6, okay? Fine. Now we have computed the average turnaround time and average waiting time. Now let's see what is the schedule length, okay? See, to compute schedule length, our scheduling algorithm has started scheduling processes starting from time unit 0 itself, right? And till time unit 19, our scheduling algorithm has been scheduling processes, right? So the schedule length is nothing but 19 minus 0, which is 19 itself. Okay, schedule length is 19. Fine. Now let's compute the throughput. Okay, throughput is nothing but number of programs processes executed per unit time. Now the total number of processes which have been executed is nothing but 6 throughout this journey. And how much time unit? It is still 19, right? Schedule length is 19. So 6 by 19. 6 by 19 is the throughput. Okay, fine.